the first physics practical assignment for this semester, your first physics practical assignment. Now, like I usually tell the other students, that this is not meant for you to just copy. It's meant for you to understand what is expected of you in other practicals in preparation for your examination. All right. Now, this practical, we are given some values. We are given xg, and that was given as 50.00 centimeter. All right. Now, the general idea here in this physics practical is that all measured value should be in 2 decimal place, and all calculated values should be in 4 decimal place. And you can see that as what is available in this particular table. Now, your SP for this practical was given as these values here, which are 5.0, 10.0, 15.0, 20.00, 25.00, 30, and then 35. And then your T1, the time, which we are also giving here. You have this one as your T1, and then this one here as your T2. Then you calculate the mean. The mean means add T1 plus T2 divided by 2. So if you add 15.31 plus 14.84 divided by 2, you are going to have this value. Of course, also note that you can see the 4 decimal place here, which is 1, 2, 3, 4, because the mean is a calculated value. Same thing applicable to this one. You add this plus this divided by 2, which is this. You add this plus this divided by 2, which gave us this, and then this whole thing continue like that. Now, to get the period, they gave you period, my dear students. The formula for period is equals to the mean of the time, the mean time in seconds divided by number of oscillation. Now, they gave you the time for 10 oscillation. So our number of oscillation is equals to 10. So our period, my dear students, is equals to what? The mean divided by 10. And this is our mean here. So I divided it by 10. For each of them, you have 1.5075, 1.4965 for this one. All I did was to divide each of these by what? By 10. All right? And that was what I did all through to get this period here. Divide everything you have here by 10. Is that understood? Then the next thing is H. Now, to calculate your H, subtract SP from SG. Your SG is a constant, which is 50. These are your SPs here. So for the first one, it will be what? 50 minus 5, which gave us 45. Also take note of the calculated value for decimal place. Then the second one is 50 minus 10, which is SG minus SP, which gave us 40. And then you do that for the rest of them. You can see this one, 50 minus 35 for the last one, will give us 15.00. Then you have H square. How do you get the H square? What you have here, each of them, square them. So 45 square is going to give us this. 40 square is going to give us this. 35 square is going to give us this into 4 decimal place. And then this one will give us this. This one will give us this. 20 square will give us 400, and 15 square will give us 225. So that was how this particular one was gotten. Then the next one is HT square. Now you don't have T square in this table. So in your calculator, you are just going to do that one quickly. 1.5075 square. Any answer it gives to you, use it to multiply the H. In this case, for the first one, 45. So you have your period, which is your T. You square it. 1.5075 square. All right? Come in. So we have 1.5075 square multiplied by 45. It will give us this. This rather. 102.2650. Same thing you are going to do for the 1.4965 square multiplied by 40. Going to give us the 1.4575 1.4575 square multiplied by this will give us this. And that is the same thing you are going to do for each of them. Multiply them or square them, then use them to multiply what you have in H. For instance, this last one will be 1.6535 square. Use it to multiply your 15.00. That will give us this. Now, the next thing is you should plot a graph of HT square against H square. Now, to plot that graph, it's a very simple something. We will need to draw some line. All right? We need to draw some lines. Now, what are some of these lines we will have to draw? Let me see if we can actually draw some line here. Okay. This is line. Let me choose a color. Use this one. Shall we use... Let's use this color to draw our line. So for the line, let me start the line from somewhere around here. This place here will be okay. So I have my line drawn from beginning to the end. You see the line must be drawn from beginning to the what? To the end. Then I will draw the other one here also from beginning to the end. Now, having drawn this line like this, the next thing we are going to do now is to the next thing we are going to do now is to write our axis. Now, the graph, they ask you to plot a graph of HT square against H square. It means HT square would be on your y axis and H square will be on your x axis. Is that okay? So you come here and say HT square here. Is that okay? And then you come here, you see how I put my arrow here, you must put all these things in your graph. These are the things they mark. And then here you have H square. Now, what is the unit of HT square? Of course, it was centimeter. You are supposed to put it bracket. It's supposed to be something like this. HT square bracket centimeter second square. You put it there. Then this one will be H square. H square. So here will be what? A square bracket what? Centimeter square. Is that okay? Don't know why this one is shaking. All right. Now, at this point in time, the next thing you are going to do now is here put 0, 0. Is that understood? Put 0, 0 there. Call me. So we have 0, 0 there. Is that understood? Now, it's not that clear. Let me see if I can get something that will be clearer. Let me use this red. 0, 0. Now, having written the 0, 0, the next thing now is for us to start putting in our, or choosing it. Before you choose a scale, write here a graph of the title of the graph. These are the things they mark. A graph of HT square against H square. Is that okay? A graph of what? HT square against H square. Write it on top of your graph. Now we are now going to choose a suitable scale. We look at the values we have here. The highest value for HT square is 102. The lowest value is 41. Is that okay? So if you want to use 102, 41, now you are going to look at your graph, depending on the graph you bought. Some of you brought graph that you can use 10, 10 and it will be up to. But for this, my graph, I should be using 20, 20. So if I use 20 here, from 0, here will be what? 20. Here will be what? 40. Here will be what? 60. Here will be 80. Here will be 100. Here will be what? 120. Here will be 140. For which of the axis? HT square axis. Is that okay? So you are now going to write this K. K, write K. Let this centimeter, yes, about 2 centimeter. 2 centimeter represents 20 units because 2 centimeter represented 20 units here. 20 units on HT square axis. So you write it that way. Is that okay? Let 20 centimeter represent 20. Let 2 centimeter represent 20 units on HT square axis. If you measure this, it may be 1 centimeter depending on your graph. So all you just need to do is to measure the from this thick line to this thick line. Anything it gives to, if it is 1, you can put let 1 centimeter represent 20 units on HT square axis. When you measure it, if it is 2, then let 2 centimeter represent that. Now, coming to this axis, the highest value we have here is about 2025. The lowest value is about 225. Is that okay? So we can decide to use 200. Let us use 200 and see if it will be able to accommodate. So here is 200, here is 400, here is 600, here is 800, here is 1000, here is 1200, 1400, 1600, 1800, 2000. Then here is 2200, 2400. So it was able to. So you are going to say let 2 centimeter represents 200 units on H square axis, which is your X axis. Then this one is your what? Y axis. Is that okay? Now that you've written that, the next thing we are going to do now is to start plotting our graph. Now, you are going to do measure approximations. Are you getting it? Your graph may not necessarily be exactly those values you have there. You are going to make measure approximation because of the nature of your values. Now, you are plotting a graph of this against this. When it was 102, it was 2025. 102 is very close to 100. So you just move it a little bit above 100. And this one is what? 2025. 2025 is like one line ahead of 2000. So this is 102, one line ahead. Then this 2000. Then 2025 will be somewhere, this 25, 50, 75, and then 20 will be this. So 25 will be somewhere very close to this place here. You mark it. Are you getting it? So you have 102 and then 2025. Then you come back here. The other one is 89 and 1600. So 89 will be very close to 90. If yes, 80, the middle one is 90. Are you getting it? So 89 will be very close to this, and this one is what? 1600. So you mark that point. Then the other one is 1225 and then 74. 74 will be very close to 70. This is 70. 74 is just a line above 70. Are you getting it? Or 2 lines above 70, 74. Then you have 1225. This is 1200. 1225 will be somewhere around here. Are you getting it? Somewhere around here. And this will be 74, somewhere around here. So you mark that point too. Is that okay? Then the next one is 963. So you have 63, very close to 60, and then 900. This is 800. This is 900. This is 60. 63 will be somewhere around here. You mark that point. This is 900 because this is 800, 900, 1000. So you mark that point. Then the other one is 625 and 55. 625 is very close to this 600. This is 650. 625 is in between. And then you have what? 54. This is 600, 650, 625 is in between 650 and 600. And then you have 54. Here is 50, this line here. 54 is just above a little, which is somewhere around here. All right. Then the next one is 446 approximately. This is 400. This is 40. Are you getting it? So 46 will be 1, 2, 3. Somewhere around here. That's where you have your 46. And then the last one will be 225 and 41. This is 200. 225 is just above 200, which is somewhere around here. And then you have 41. 41 is very close to 40. 225, somewhere around here. 41, somewhere around here. All right. So this is your plot. Now the next thing is to choose our line of best fits. Now for us to choose our line of best fits, we have to rule which line do you think, or which of them do you think has the best line. All right. So you have to rule. This value is kind of too thick. Let me change the thickness. All right. It's too thin now. I think this one is okay. Now, my dear student, the line of best fit must be in such a way that some of the values will fall out and some will fall in. And your line must reach the ending of your graph. Are you getting it? So you can see how I am ruling it. And then it must reach the ending of your graph. This one is not the straightest you can get, but I think it's okay like this. Is there a way I can actually edit this particular line? Ooh, if it's that app I used to use, you should be able to edit. Okay, let me use hand away. It's erasing this sheet. Here is 20. All right. Okay. Think I can exactly. I can elongate this one. And I decide to delete this one off so that. All right. So you see, this is my line of best fit. Now, the line of best fit must be in such a way that each of the values will scatter. You see, this value here entered well, this one entered a little, then this one entered well, this one entered well, this one entered well. At least 3 values entered very well. If I still want to rearrange it in such a way that, okay, depending, I'm not using a proper graph here, but depending, you can actually see that these values entered. All right. So this is our line of best fit. You see that the values are scattered. We have some values lower while there are some higher. The line passes through the middle. This is our line of best fit. Is that understood? So if you may be asked to calculate the slope, but the only thing they just ask is to plot the graph. If they ask you to calculate the slope, it's very easy too. All you need to do is, okay. If they ask you to calculate the slope, you use broken lines to do that. But let me use this one. If they ask you to calculate the slope, you use broken line. Take 2 points in the graph. You can decide to take, and the 2 points must be large enough. All right. You can decide to take Shimo. It's too big. And I don't even like that color. Can decide to take this point here that entered, or not necessarily be this point, or can decide to take this point, then take this other point here that also entered. Or you take that point and then rule it down. But ruling it down to that place would be very deleterious. So what I'm going to do is take this point here, then rule it down to this point like this. Is that okay? And then trace it down to this point, and then trace this one down. It's not that clear, but I just pray you are able to see it. It's purplish in color. Are you getting it now? So our slope, you are not to write the slope inside the graph. You write it outside. Is that understood? The slope is equals to change in y all over change in s, which is y2 minus y1 all over what? S2 minus what? X1. That is our slope. So you are going to take this value here, our y, which was what? 89 point something, I guess. That was the value that was there, 89.585. So you take that value, let me write it here, 89.5 what? 5805 minus y1 is this value here. The value that we actually ruled here was 40. Are you getting it? If you trace this one down, this was the first point we took here, down to this point, we give you that 89 point something. Then here was 40, so you subtract it from 40.000 divided by S2, this value here, down, which was what? 1,600 minus, then X1 is this value here, which is what? 300. Your value is supposed to give you 0.04 something. If I can still remember, 0.01 something. If I can still remember, all right? So that will give us 89.5805 minus 40, which is equals to 49.5805 divided by, we have 1,600 minus 300, which is 1,300. So you divide 49.5805 divided by 1,300 exactly. This is the answer, which will give us 0.038, approximately 0.04. This is what you are expected to get as your slope. Is that okay? Because we have done this practical over and over again. When you substitute this 0.04 into one of the equations that they are going to give to you, your answer will be 9.8, which is the value for G, gravitational constant. So thank you very much for your time. This is just one out of our numerous lecture series. We offer coaching in mathematics, physics, chemistry, biology, and some help in GST, especially during exam time. And our learning is also very flexible. We have flexible learning options. You can either opt in for online class like this one, especially for those of you who are having things to do in the evenings, all right? Or you can visit us at LT3, right? LT3 from Monday till Saturday by 4 p.m. daily. All right. Thank you very much for your time. We'll see you in the next one. Bye-bye.